Okay, so the problem we want to solve here is what happens if a girl who's holding a pumpkin standing on a skateboard, and remember, she's standing still here, she's not moving, she's going to throw the pumpkin to the right, and as you probably know, she's going to move to the left. And so we're going to use momentum conservation to study what happens in this problem. So the thing to recognize is that on this girl and pumpkin, there are no external forces. So there's no forces from the outside acting on them. Gravity, of course, is pulling down, but the normal force is pushing up and counteracting that. So the important thing to learn here is that there's no external forces. So what that means is we're going to start every single problem this way. The external force times the time that it acts causes the momentum to change. And if we can determine that the external force is zero, it means that the left-hand side is zero, and that means the change in momentum is zero. And so if the change in momentum is zero, that means that the final momentum will equal the initial momentum. Okay, so this is what we call the conservation of momentum. So we're going to use this idea to build ourselves an equation to solve this problem. So let's go ahead and write down what we know. We are going to use the subscript G for the girl and the subscript P for the pumpkin. And what we know, we're going to have the mass of the girl, and from the problem we can figure out that is 50 kilograms. And we're going to have the mass of the pumpkin, and from the problem we can also figure out that that is 10 kilograms. So what we need to do is, for each of the objects in our problem, we need to find the velocity of the girl initially, so I'll do that, and we need the velocity of the girl finally after she throws the pumpkin. We're going to have the velocity of the pumpkin initially and the velocity of the pumpkin after it's thrown. That's final. So because they are standing still, the initial velocity of the girl is zero and the initial velocity of the pumpkin is zero. She throws the pumpkin to the right with a speed of 4 meters per second. So the velocity of the pumpkin after she throws it is positive 4.0 meters per second. That's how fast the pumpkin is moving to the right. And our job is to find the velocity of the girl. So we're trying to find this. Okay? So now, we need to write out what this means for our problem. Okay? And I know you guys don't like doing this, but every single problem you've got to start with this idea, state the conservation of momentum principle, and then write out what it means algebraically. So the final momentum is going to be the mass of the girl times the velocity of the girl final, plus the mass of the pumpkin times the velocity of the pumpkin final. That's the final momentum. And that's got to equal the initial momentum. The initial momentum is going to be the mass of the girl times the velocity of the girl initial, plus the mass of the pumpkin times the velocity of the pumpkin initial. So after you state that the final momentum equals the initial momentum, write out the final momentum, write out the initial momentum algebraically. That means we're not using numbers yet from over here. We're just writing it out. Now, we are trying to find the velocity of the girl final. So our plan is to solve for the velocity of the girl final, which occurs right here. This is what we're trying to find. Now, before we go solving for it, getting it by itself, let's see if there's anything that's zero. So we know from over here that the velocity of the girl initial is zero. So the velocity of the girl initial is zero, and so any expression that includes that as one of its products is also zero. We also know the velocity of the pumpkin initially was zero, so this is going to make our problem easy. That's also zero. So what we have left is this term plus this term equals zero, and we're trying to solve for the velocity of the girl final. So if we want the velocity of the girl final, the first thing we're going to do is bring this to the other side. So I'm going to have negative mass of the pumpkin, velocity of the pumpkin final, and that equals the mass of the girl times the velocity of the girl final. To get the velocity of the girl final by itself, I will divide both sides by m sub g. So I'll divide this side by the mass of the girl, divide this side by the mass of the girl. Those cancel. And finally, we have the velocity of the girl final equals negative the mass of the pumpkin times the velocity of the pumpkin final all over the mass of the girl. We're going to go ahead and plug in our numbers. And after we plug in our numbers, we can evaluate. So 10 times 4 is 40. 40 divided by 50 is 0.8. And we have to remove that negative sign. This is negative 0.80 meters per second. And that's the velocity of the girl final after she throws the pumpkin. So that is our solution. And that makes sense because the pumpkin was a lot lighter than the girl. So if the pumpkin moves 4 meters per second to the right, the girl moves at less than 4 meters per second to the left. And so this shows us that the girl is moving to the left and that her velocity is about 0.8 meters per second. So that's how we're going to solve the first couple problems.